Now that you're familiar with the vocabulary using probabilities, we are ready to start talking about how we calculate probabilities. In this lesson, we're going to be calculating empirical probability. Empirical probabilities are probabilities that are found by actually performing the experiment. Now, we also have something called theoretical probabilities. With theoretical probabilities, we don't perform the experiment. We use theory to calculate probabilities. The probabilities that we're going to be calculating in this lesson are going to be calculated by looking at the experiment that was performed. We're going to see the outcomes that we saw on that experiment. We can calculate the probability of event A as follows. We would take the number of times A occurs divided by the number of times the experiment was repeated. For example, let's say that you were rolling a die and you rolled the die 1,000 times. Then here on the denominator, you would have 1,000. That is the number of times the experiment was repeated. And let's say that out of those 1,000 times, you saw the outcome 6, you rolled a 6, 180 times. So the empirical probability of rolling a 6 would be 180, which is the number of times we saw a 6 being rolled, divided by the number of times that the experiment was repeated, which is 1,000. Okay, so that is how we calculate empirical probabilities. One thing that I want to mention here is the notation that we're using here. Instead of writing the probability of event A, we are writing P of A. So that is how you can read this, P of A. Or you can also say the probability of A when you read this notation. So for example, if I wanted to denote the probability of rolling a 6, I can go ahead and say P of 6. Okay, we know that we're referring to the experiment of rolling a die. Here we're referring to the probability of rolling a 6. Okay, so that is the notation that we're going to start using in this class. That way we're not doing a lot of writing when we're making calculations. Let's go ahead and calculate probabilities from looking at an experiment. The table below contains the number of M&Ms of each color that were selected from a bag. Answer the questions below based on the experiment. Round to 4 decimal places. So here we see that 481 blue M&Ms were selected, 371 brown M&Ms were selected, 483 green M&Ms were selected, and so on. Now here at the end, where we see the total, we see that 2,620 M&Ms were selected. Okay. So what is the experiment here? The experiment here is selecting M&Ms from a bag. How many times was the experiment repeated? Well, we see that a total of 2,620 M&Ms were selected from the bag. So this is the number of times the experiment was repeated. That's going to help us calculate probabilities. Find the probability of randomly selecting one M&M of each color. Okay? So we have 3, 4, 5, 6 different colors. We're going to need to calculate 5 different probabilities. Let's start with the probability of selecting a blue M&M. Instead of writing the probability of selecting a blue M&M, I'm just going to write P of blue. We know that this stands for the probability of selecting a blue M&M. Okay? The probability of selecting a blue M&M is going to be, let's look back to the statement we have here above. It's going to be the number of times blue can occur. We see that the number of times blue can occur is 481, divided by the number of times the experiment was repeated. The experiment was repeated 2,620 times. So here on the denominator, we're going to have 2,620. Go ahead and enter this on your calculator. You should be getting 0.183587786 I'm writing all the values that I'm seeing on my calculator to remind you how to round. Now let's go ahead and round. We're going to round to 4 decimal places. Let's put an arrow on the place value. We're looking at 5. The value to the right of 5, which is 8, is going to help us decide how we're going to round. Since 8 is greater than 5, we're going to round to 0.1836. Okay, we're going to round up. And so this is the empirical probability. And so here the probability of blue is approximately 0.1836. We're going to keep this probability as a proportion, as a decimal. We could write the probability as a percentage. Let's do a few more. Let's find the probability of selecting a brown. The probability of brown is equal to the number of times we saw a brown being selected, which is 371, divided by the number of times the experiment was repeated, which is 2,620. This should give you 0.1416030,534. Again, I'm writing all the values that I'm seeing on my calculator so that we can review how to round. Let's go ahead and place an arrow on the place value. We need 4 values after the decimal, so we're looking at 6 here. We need to look at the value to the right of 6, which is 0. Since 0 is less than 5, we're going to round to 0.1416. Let's do one more. Let's find the probability of selecting a green. The probability of selecting a green is the number of times we saw a green being selected, which is 483, divided by the number of times the experiment was repeated, which is 2,620. Go ahead and type this on your calculator and round to 4 decimal places. When you round to 4 decimal places, you should get 0.1844. We are calculating these probabilities by looking at the results of the experiment. Notice, we know that they pull a total of 2,620 M&Ms from the bag. We don't know how many M&Ms we have inside the bag. We don't know what would happen if we continue to pull M&Ms from the bag, okay? We're calculating these probabilities by just looking at the results of the experiment. I want you to go ahead and find the probability of selecting a orange M&M, the probability of selecting a red M&M, and the probability of selecting a yellow M&M. I'm going to leave those 3 up to you. I want to make sure that we do part B and C together. In part B, you're being asked to find the probability of randomly selecting one M&M that is brown or green. So let's write P of brown or green. We are okay with selecting a M&M that is brown, or we are okay with selecting a M&M that is green. One or the other. How many ways can you select a brown M&M or a green M&M? Well, we have 371 brown M&Ms and we have 483 green M&Ms. If we add those values, we're going to have the number of times brown or green can happen. Now, we're going to be dividing. Now here, we're still going to be dividing by 2,620. If you're doing this on your calculator, you need to place parentheses around the numerator. You should be getting 0.3259541985. Now, if we round to 4 decimal places, we have 0.3260. So notice, we were looking at the place value here. We have the value 9 at the place value. We have a 5 to the right side of the place value. 5 is going to increase 9 by 1. That means we are going to increase 59 to 60. That's how you can think. Now, the last probability that we're going to compute is the probability of randomly selecting one M&M that is green and orange. We're going to write P of green and orange. Can you select one M&M that is green and orange? Meaning one M&M that has both colors. The answer is no. We do not have multicolor M&Ms. The number of ways you can select the M&M that is green and orange is 0 out of the 2,620 times the experiment was repeated. This is going to give us 0. So look at the difference here. In part B, we had brown or green. It is possible to have a M&M that is brown or to have a M&M that is green. So this or doesn't mean that one M&M. However, it is not possible to have a M&M that is both green and orange. Be careful with the vocabulary that is used in statistics.